Hello and welcome everyone tuning in, whether it's morning, afternoon, or evening in your part of the world. I'm Nadia and I'm thrilled to be your host today for a Microsoft Reactor live stream. Before we dive into the main event, I'd like to remind everyone about our Reactor Code of Conduct. Our aim is to cultivate a positive and inclusive environment for all the participants, so let's keep our interactions respectful and supportive. Today we are joined by Deep and Jyotsna, who are both cloud solution architects here at Microsoft, and they'll be taking you through how to build your own Copilot, so a workshop on crafting chatbots with AI. Throughout this session, feel free to drop your questions in the chat and we'll do our best to address as many as possible. And we'll also be sharing additional resources and links in the chat box as well. For those who want to revisit today's session, you can catch a recording later on our Reactor YouTube channel. But without further ado, I'd like to give a warm and virtual round of applause to our fantastic speakers, Deep and Jyotsna. Welcome, Deep. Welcome, Jyotsna. Over to you.
Thank you so much, Nadia. Lovely to be here. Hey, everyone on the call. We're both super excited for today's session on everything around building your own Copilot. So essentially, Copilot, as you all might know, is a tool that I personally use at work and simply find it just beyond amazing for productivity and collaboration purposes. But what's really, really cool about Copilot is that anybody can create their own custom one, tailored to your needs, leveraging your own data. So if you move on to the next slide, Deep, Copilot is essentially, having your own recipe book for boosting productivity with the seamless integration of intelligent search, chat, and generative capabilities into your workflow. So on the next slide, what do we mean by Copilot? Copilots are essentially intelligent apps that enable the use of natural language, speech, and vision to find better and more relevant answers to questions and help users ideate, create, and deliver their daily work. So a copilot can also learn from your users' preferences, behaviors, and data to provide your own personalized and relevant assistance. So on this slide, let's continue talking about a more technical and formal discussion of Copilot. So it's essentially a conversational multimodal UX that attaches to your app and uses modern AI to assist with complex cognitive tasks. But what sets this apart is its innovative development plan. So essentially, developers don't need to be AI whizzes to get started. It's as easy as integrating your API in the app. Through its unique architecture, you can customize the Copilot to fit your app perfectly. Whether you want to use pre-made models, tweak them a bit, or even bring in your own, the choice is simply yours. But why just stop there? This thing's going to be everywhere. From making searches easier to boosting productivity, to beefing up your security. Copilots are set to be the ultimate multitaskers, just revolutionizing the way that we work. So, now that we know a bit about copilots and a bit about their capabilities, I'm excited to show you how to build one. But for this, we do need a use case. So, on the screen here, you can see Amrita. Amrita works for a fictional company called Contoso Electronics. One day, she asks a simple question about her health plan at Contoso. Where does she go? You guessed it, the employee handbook. However, to get through the information, she needs to go through hundreds and hundreds and hundreds of pages. We've all been in a situation like this before, and it can be quite frustrating. So, with that, let's help Amrita build a co-pilot to solve not just her problem, but everyone else's problem as well. In order to do this, we do need to gather requirements for our Copilot. So the first point is you want your Copilot to be able to provide answers to the questions that you provide. For this, the Copilot would need to search through the company policy documents by leveraging the power of AI to handle all the data that we feed into the system. But here's the kicker. We do need to whip up a prototype fast and show it off to Amrita. So now that we have our requirements, let's use an open source demo from Microsoft to kick off our Copilot project. So what you can see on the screen is just a screenshot of that OpenAI demo. It's one of the many available for various scenarios, architectures, and programming languages. It's very popular and very flexible. It's tested by many, so definitely a trusted choice for your diverse use cases. Awesome. So, before we get started, just wanted to take you through the architecture behind our demo. So firstly, you can see the user on the left that engages with a web interface, with a web chat interface, which we are hosting on Azure App Service. This is kind of like chatting with your friend, but only this friend is very knowledgeable. And you can see behind the scenes, our app is tapping into the language and learning model at the top, which is our open AI source, so GPT, to handle the conversation back and forth. So this is what you will see on the interface. It's the brain power behind the Copilot's responses. But we do need to bring in our Contoso policy docs. And this is where we use Azure AI Search. This tool helps serve as our knowledge base, housing all of our policy docs in one accessible place. So now those policy docs might come in all sorts of formats like PDFs. This is where we will use a service called Azure Document Intelligence Service to process them. So this service specifically can handle all sorts of forms and documents and extract text and tables like a pro. So once we've extracted all that content, we index it into our search engine, making it super easy and easy to find and reference. Awesome. So now let's do a quick check-in in the audience. So a quick show of hand or maybe a response on the chat. Who amongst us are developers? Awesome. Can see a few responses. And maybe keep commenting if you've ever used Azure Developer CLI. But for those of you who haven't, Azure Developer CLI is just one of the many Microsoft tools that offers offers to turbocharge your software development journey, especially when it comes to rapid prototyping. So with just 4 simple commands, you can kickstart your project. So firstly, clone the repo, navigate into the relevant folder, log into Azure, and run the azdup command. And that's it. In just less than 1 hour, your application, along with all the infrastructure, will be up and running. So with that, I would like to now take you through a demo of our basic web app that you can see. So we've pre-recorded this video already for time management purposes. So what you can see is a basic web app written in JavaScript and React. It's a chat interface, and you can see we are feeding in a question. And you can see there the response is generated. So what GPT has done is it's directly answered our question. It's not only done that, but it's also provided citations for where the information came from. So we can have a look at this. Now, before we take a look at this, this is general like best practice when it comes to UX for Copilot. So providing references and the most up-to-date information. So now on the next slide, let's take a look at the citation. So if we click on the citation, yep.
There you go.
Awesome. We can see the original PDF on the side there where this information came from. Now, the question that we actually asked the chat was quite difficult to answer. The differences between the plans on Contoso policy are spread across multiple paragraphs that we can see here. So it's grabbing questions and quotes such as emergency services, mental health, substance abuse, as well as dental exams and much more, right? So what GPT has done here is it's taken all of this fragmented information, read it, and summarized it to answer the question directly. So now let's take a look at the process behind all of this. In the next slide, yep. So if we close the citation and click on that light bulb button there, we can look at the thought process behind this. You can see there are quite a few steps there, and now we are going to talk about them in detail in just a moment. But before that, now that we know what the app looks like, let's dig into exactly how it works. So what you're essentially looking at here is a Python SDK example from our repo. Essentially, the AI is just an API. It all starts with the basic completions call. So in the middle, you can see a completion takes the message input and gives a message response. In the middle, you can see we've also added some parameters like the model and a tuning parameter like the temperature, which controls the randomness. And at the top, the messages are formed like a conversation turn by turn. First, the user speaks, followed by the assistant. There is a special kind of message at the start of the conversation, the system message, which is generally hidden from the user. This message contains special instructions for the GPT model. So you can see that it wants the model to talk like a pirate. It essentially shapes the behavior of this conversation. So you can see here, we're going to talk about tax for a pirate audience. So the response is, excuse my pirate voice, Almighty.
Sorry.
The due date for your taxes be April 15th in the year. I'll just stop there. So apologies in advance for that. You can see that this response has been taken by a US example. So as you all know, taxes in Australia are due in October, not April. So this is one of the first challenges that we need to solve using generalized foundation models, which is knowing exactly the content of the user. So how do we solve this problem? This is where I will talk a bit about a design pattern called retrieval augmented generation. Now, in order to understand RAG, we must first understand the challenges of foundation models. So on the next page there, we can see that we can see that the challenge behind foundation models is that we only have general knowledge that is frozen in time. So it's not giving us the most up-to-date information. Specific use cases require specific data sets. So like our example below, you won't have your company documents readily available using a foundation model. And lastly, it has a limited context window, which does incur costs with repeated use. So now, in order to solve this problem, this is where RAG comes in and adds that extra layer of relevant data to the prompt in order to generate a more specific response using a generalized model, also called grounding a model. So in the next slide, let's walk through exactly what the RAG process looks like. So again, at the top here, we can see it starts off with a user query that talks to the retrieval function. Now, the role of this function is to retrieve specific data based on that query. It fetches it from the data source, which could be an API or a database or a vector. And the next step is we need to augment our prompt. We already have a system prompt and we already have our user query. All we need is to get that retrieved information. Now, we'll add the retrieved information that's relevant to this query, and when we call GPT, it already has that information readily available for us. So with that, I am now going to hand over to Deep, who will go through this process in more detail using the demo that we just showed you. Over to you, Deep.
Awesome. Thank you, Jyotsna. Look, before we keep going, I just wanted to quickly introduce myself and also just touch base with the audience, see if we have any questions, and just keep those questions coming as well. So I'm Deep. I'm a cloud solution architect. I've delivered this workshop a couple of times before, and what I'm really keen to hear is different use cases that you might think of or that you might have already thought of prior to this session. So yeah, keep those comments coming. And yeah, if there's a use case that we think that it's appropriate to talk a bit more about with the rest of the audience, I'm happy to take that and yeah, talk a little bit more about how to use OpenAI in a certain way. So while you were talking, Jyotsna, someone in the audience mentioned around how does Azure know when to use OpenAI or the internal Azure AI service, AI search service. I mean, I'm happy to give this, maybe I'll start off and then Jyotsna, you can add to what I say as well. So with the OpenAI service and the AI search service, they're different, they form different components of this RAG model. The OpenAI service is over here on the right where it says call GPT. That's the part where we call the external API for GPT-4 and receive the results, which is a string of characters or a string of words, essentially. With the internal AI search service, we're doing more of this retrieval function. So at the start, we generate a search query. We then use that to retrieve the most relevant documents for your search query, and then feed that into OpenAI. So the reason why we need two different functions here is because the OpenAI service only accepts a certain context window. So it's a small context window. And because our documents might span hundreds and hundreds and hundreds of pages, that doesn't necessarily fit into the context window that ChatGPT has. So that's why we need an additional search service, kind of like a Google or a Bing, but with your own personal company's documents so that you can search through them before we call OpenAI search service. So we can forward the relevant information to OpenAI rather than giving OpenAI every document that's been generated by your company. Did you have anything else that you wanted to add to that?
No, that's spot on, Deep. Thank you.
Yeah, the other thing is, yeah, if you have any questions or any use cases that you want to float with us, please just reach out in the chat. I know there's a few comments coming through as well. Pirates don't pay taxes. Thanks for reminding me to pay taxes. Yeah, look, we're not super keen about taxes, but that it is what it is. I was wondering why you use temperature equal to 0.7. We normally work with factual data in RAG, and maybe lower temperature is much better. I'd appreciate if you could clarify this. So generally with temperature, it's based on the amount of randomness in the model. So when you can tweak that as a metric to change the amount of randomness. In this example, we have used 0.7 as an example, but yeah, a lower temperature would be better technically when you're using RAG because you want the model to be based on the data that you've put in. And the data that you've put in, you want it to reference that data. You can also tell the model, so in your instructions, in your system prompt over here, you can also tell the model that, hey, only use the data that I've given you. And that will do something to actually give you the answer that you probably want. But again, there is no one size fits all. There's no actual answer to this. You just have to play around with the different metrics and see how that works. Does internal retrieved, maybe confidential info go to the OpenAI API? So yes, it does. So if you're looking at here, after you've retrieved this information, you will need to call GPT so it can take that input and then create an answer or an output for you. There's a couple of caveats with that though. You can send it over private networking. So with Azure, you're not using OpenAI or the open public API that OpenAI provides. Instead, it's a private API, and you can actually restrict who gets access to that API. So you can do it with private networking, so you know it's all encrypted. Also, with Azure OpenAI compared to the OpenAI API, with the Azure OpenAI API, we do not use your data to train the models. And that's something that's in our service agreement. That's something that's in our licensing terms. So, and this is across all of our enterprise grade products. So not only OpenAI products, but also GitHub Copilot. We don't use any of your code to train GitHub Copilot. So while yes, internal information retrieved, maybe it will be going to OpenAI because of this OpenAI call, but we're not using it to train that OpenAI model. And we're also passing that information through a secure private tunnel. So it's not exposed to the public internet. So with both of those, we think that it makes it more secure. And so, it's possible that we can utilize this flow even for companies with maybe sensitive policy documents and things like that. You would not be using this for someone's bank account or someone's information about their social security number and things like that. But you can use this for use cases regarding policy documents, for example. Anything else to add about those two, Jyotsna?
You're smashing through them. No, good job, Lee. That's great.
We are at 6:22, so we do have we do have time. So feel free to bring in more questions, and if you have use cases, again, just type them into the chat, and we can have a talk about use cases. I also want to talk about some of the common use cases that I've seen in the past as well. So we can do that closer to the end. Awesome. Let's continue. So we've reviewed the step-by-step flow of how the GPT-4 takes a prompt, takes the most relevant information from your databases, and merges those two together and utilizes that information to give the most relevant answer or outcome for the user. And that's all shown here in that thought process there. Let's go through a bit more of a deeper dive on each of those steps. So when you send the query, that query then goes into the retrieval function that Jyotsna was talking about. What does that actually look like? So here we've got, let's generate a query from this user, this prompt that the user has given us. So the prompt is the same prompt that we put in, of something about the health plan. So what is included in my Northwind Health Plus that is not in standard? And in this example, it then takes that and says, generate search query for that prompt there. So what is in my Northwind Health Plus plan that's not in standard? OpenAI then takes that question. So it takes the prompt to generate a search query. It also takes all this other information around meta prompts, and it then generates the search query. So the search query that's generated from this is Northwind Health Plus Plan Standard Inclusion. The way that I want you to think about this is kind of, if you were using a search engine like Google or Bing, and you had a question in your head, you generally wouldn't type in the question word for word, because you know that Google works in a certain way and it wants you to put in keywords that could be found in your relevant answer. It's very similar here, but instead of you having to do that translation between your question and the search query, GPT-4 does that translation for you. So it's gone from the question to a search query. So that's step number one. Step number two is about using the data source. So we, as I mentioned before, we can't necessarily put all the hundreds and hundreds of pages in the context of GPT-4. It won't fit. And also the more and more context you put, the less relevant your results become. So one of the ways we've found to fix this, and one of the architectures we've found to fix this, is the retrieval augmented generation model, where we're using search results from Azure AI Search to augment the answers that GPT-4 is able to give us. So we say that, okay, from the files that you've ingested, Azure AI Search, can you find the ones which have anything to do with this search query? the one about standard inclusions for the Northwind Health Plus plan. And just like any other search engine, Azure AI Search, which again, it's private to your organization, it goes and retrieves the most relevant documents and gives you some search results. Now, I want to draw your attention to a couple of different parts of the search result. One thing is called the embedding, which we'll get to in a second. It's a numerical representation of the result. It also has the source page, the source file, which are where it's got that information from. It's got a score and a re-ranker score. The score and the re-ranker score, I don't want you to look at the absolute number because as you can see here, it's not necessarily out of 1. This one's 2.4 and this one's 0.03. It's not necessarily the actual score that matters. It's more the relative score between different search results. So that's how the augmentation then works. So it then takes that data, the answers that AI search provides, and it passes that into GPT-4 along with the original query that the user had, as well as the system prompt. In this case, the system prompt that we discussed before was all of this stuff. So below is a history of the conversation so far, generate a search query, do not include source file names, etc., etc. So this is setting the context before the user comes in and types in their question. That's what the meta prompt or the system prompt is. So then you have a culmination of all of these three. We then take that and augment the prompt. So this is the context here. So you have, as I mentioned, the initial query, the initial system prompt. We have the query that the user placed. We have sources and we have extracts from each of those sources that Azure AI Search gave us. And then we pass all of that into the GPT-4 model. So at the end, we have a result like this, where we have the citations from the relevant sources. We have the results, the actual results. So in this case, it says that the Northwind Health Plus plan includes coverage for hospital stays, doctor's visits, lab tests, etc. And it also says that this plan offers a more comprehensive coverage than the Northwind standard plan, which is what we asked initially. Now it's the fun part. Now it's the part that we're going to go a little bit technical and talk about vectors and embeddings. The way that I like to present this is try to have a think about what the word green means to you. What comes to your mind when you think of the word green? Normally when I'm up on stage, I ask for, question and answer, but since we only have Jyotsna here, maybe we can ask her, what comes to your mind when we say the word green?
Oh, the Grinch. No,
yeah.
yeah.
That works. Yeah, Grinch is a valid answer. What else?
Yep, grass is
What
a more
about-
appropriate answer, probably.
What about solar panels? What about like being green, using a recycle bin, for example? Trees, yeah, tree color. That's it. Color flashes in mind. Nature. Those are all correct. There are so many different grapes, yeah, vegetables. Yeah, a lot of different meanings for the word green and pop into our heads. And what these are semantic meanings. So these are words that are related to the word green. They're not necessarily related in terms of the number of letters or the letters themselves in the word, but it's more related in meaning and language. Now, this is difficult because different languages will obviously have different words for the word green, and they might have different words for your related words as well. So what we need to do is we need to help computers to understand what is closely related to that word. And this is where semantic meaning or semantic or vectorization comes in. Semantic search or vector search comes in. So if we do a guess here, I'm turning green and I'm growing green. Which one is more eco-friendly? Which one sounds more eco-friendly? Again, Jyotsna, you're my guinea pig, so.
That's an interesting one. Yeah, I agree. Going green.
Going green?
Yeah.
I'm glad we're on the same page. So definitely, as soon as you think of these two words, you think, okay, which one is more eco-friendly? And immediately you can say that one of them is more eco-friendly than the other. What that means is that, hey, we have this meaning that we attach to words that are placed before and after a certain word. And this doesn't really translate to computer and text meaning really well. So think about it. If I ask a computer which one of these two is eco-friendly, how are we going to determine which one is more eco-friendly? So the way to do it is by using embedding models and have our computers learn from the way that we use language day to day. Embedding models are a way of representing information. So not only text, but you can also use this with images, audio, and representing them in a vector space where the locations are semantically meaningful. As an example, I have mapped different groups of words in here. Maybe you've got some animals that you do eat on the top left and some animals that you don't eat on the bottom left. And Jyotsna's looking at me funny because she's vegetarian. But there is, some fruits and vegetables over here. And then maybe you've got Apple the company down here, which is very different from Apple the fruit. So representing these in X-dimensional space, not just in 3-dimensional space as we have here, can help a computer to determine what I'm going green and I'm turning green, which one is more relevant to the word eco-friendly. So what happens if we do that? What happens if we do that mapping between I'm turning green, I'm going green, and eco-friendly? Well, let's convert those three into vectors. So vectors are a way of numerically representing it in X-dimensional space, as we showed you just before. So in this case, we've generated a vector component for each of those words. And then what you would do is you would say, okay, well, let's take a dot product of I'm turning green and eco-friendly. What a dot product means in simple terms is you try and figure out what the correlation is between the two. So in this case, the correlation becomes 0.815 and 850. Now, I had a really good question last time, which was, why is it 0.815? Why isn't it higher or why isn't it lower? That really depends on the words themselves. So, eco-friendly is definitely not the same word as I'm turning green. Or why isn't, the question actually was, why isn't the difference between these a lot higher? I think it's because there's the word green in it. So potentially there is still a lot of vector bias. So maybe the word green skews the correlation a little bit more. But it's anyone's guess why these are so close together. And honestly, they might not even be so close together. They're all relative. So it's a relative measure to say that 0.185 is less. So I'm turning green is less similar to eco-friendly as I'm going green is to eco-friendly. It's relative. It's not absolute. Okay, semantic searching. So let's come back to how this is applied. By the way, I'm going to take a bit of a breather and a pause because we did have quite a few questions beforehand. Thanks for the explanation. That's all good. Okay, I think we finished off with the OpenAI API question.
Yep, I think the next one that came through was from Suraj. Is the behavior of trained model interface with the user be the same if it is trained under my personally trained information?
Okay. Is the behavior of the trained model, would the behavior be the same if it was trained under my personally trained information? So you mean if you as a user, so say you were using ChatGPT, you fed in some things into the context versus fine-tuning a model, would the outcome be the same between the two? I think that's what he's trying to get at, but yeah, correct us if we're wrong there. It will be. The answer is yeah, it definitely will be. With fine-tuning a model, you're feeding the model more general knowledge. You're feeding the model more general knowledge, maybe about a specific domain, like the legal domain or maybe the medical domain. You're trying to feed the model more information so it can talk in the language and the have the semantic meaning behind what it's trying to say in that specific maybe language, maybe it is specific terminology that's used within your domain. But that's what you would generally use fine-tuning for. When you're using RAG or when you're feeding in something into the model's context, you're doing the exact same thing. So RAG, all it does is it automates that process. Whereas if you were to do it manually, you could, go onto SharePoint, type in your search query, copy the results, paste them into GPT-4. You'll have essentially what is a manual RAG model, right? Where you're using a search query, you're using some form of semantic search, which is what SharePoint uses, and you'll be manually doing all these steps. So yes, in that case, those two will have the same result, but you wouldn't necessarily use fine-tuning for that. You would use either RAG or you would feed in the data into the model at runtime. Is the behavior of, okay, sorry, we've answered that question. Hi, I'm trying to figure out ways to classify emails using AI before distributing them to agents for processing. I'm curious if there's any similar case study on this topic that I could refer. That's an interesting one. We actually have some sentiment analysis models as part of the overall AI suite, or summarization models, sorry, but not sentiment analysis, summarization models as part of our AI suite. So you might not even need to use OpenAI, but if you do, it'll be a better model. So you'll get better results. Yeah, I'm not sure if I have any. Maybe Jyotsna, you can, do some digging
Research. I'll get back to
while we're talking. But yeah, we definitely do have some summarization models that are ready to go in that regard. Does OpenAI Search manage storing chat history for conversational style chatbots? No. So this is an interesting one, actually. And it's in my slides somewhere, but essentially ChatGPT behind the scenes is actually using Cosmos DB to store all of your history. And in each query, it passes all of that history in as well. So that's how it stores history. The GPT-4 model does not have any context, and does not have any understanding of what you told it in the past. And every single time you do a query, you actually have to send all the conversation history that you've had until this point. Now, some of the better, probably ChatGPT and some of the other better chatbots will summarize as you go. So they'll summarize the conversation and have some key points about what you said in the past so that they don't have to put the whole conversation history in. So that saves you tokens, as well as just in general, if it goes beyond a certain context length, you wouldn't be able to throw it all into the context after a certain point. So that's why it's really important to say that, yes, we do store chat history in Cosmos DB. There is an accelerator which already implements this, which we'll talk about in a second. That's the one that we were using. I'll give you some links. But yeah, we do have this as part of Cosmos DB, and it's not in the model itself. Are documents being vector embedded, and where is it stored? So yes, so as part of the process before, let me go all the way back to the start. And I want to, because I do want to cover this in a bit of depth. Actually, let's go to the end. That might be a better way of doing things. So we do have a few slides coming up around how to productionize this, and we'll talk a bit more about that in a second. I want to skip these. Oh, that's those slides. Okay, let me just skip back a little bit. I think it's this one here. Yep. Okay, let's get back to this slide here. There you go. So in this, what it's depicting is that you've got a document loader on the right-hand side. What that does is that you throw in your documents into a storage bucket, like a blob storage bucket. That then uses a document processor called the Azure Document Intelligence Processor. Now, this is what I like to call OCR on steroids. It used to be named Form Recognizer. It takes all of your the tables and the text from all of your documents and parses them. So for tables, for example, it'll parse them and put them into HTML. You can also make custom parsers for your tables. But essentially what it's doing is it's parsing those and making it easier to read. And that outputs JSON, HTML, or just plain Markdown files. And those files are then put into our Azure AI search engine. Azure AI search is pretty powerful. It does chunking, it does embedding, and it stores those files with the embeddings with it. So when you saw those results, they had the embeddings there. That was because Azure AI search had indexed them and already embedded each of the documents. And you can change the embedding model as well. So you can change it to the GPT-4 model. So that was the answer to that. We've got a bunch of comments about green. Does it also depend on the model used to create these vector embeddings? Yes, so different models will create different vector embeddings. We just use the ADA model, the OpenAI ADA models for this demo here. But yes, it will depend. Different models will give you a different response depending on which one you choose to use. The AI search engine, AI search comes with a few models, so we just recommend choosing one of them for the vectorization part. Okay, we are using an OpenAI model. We don't send GPT vectors. No, you don't. We send it to the answer that AI search generates. I'll take a bit of a pause there and go back to the slides because we might run out of time, but it's good to have these questions, and please keep these questions coming. Last time, I think I stayed about 45 minutes after the session ended just to answer questions. It's really good to have the questions flowing. Vector and semantic searching. So essentially you get back the results here for the search query. And you send that off to OpenAI, and OpenAI generates the responses that we saw. Now, this is a pretty cool, it's quite new technology that we've had come up quite recently. It's called the Vision engine, so GPT-4 with Vision. And what this lets you do is it lets you generate embeddings for images. So for example, if you take a PDF file like this, and you've got certain charts in it depicting different parts of your business, you can then generate different forms of vectors. So you can generate text vectors, image vectors, and images. Now, the GPT-4 model can then use those vectors in order to answer questions. A great use case for this is with someone who's maybe vision impaired, or someone who is able to maybe interact with computers using text only, and doesn't have the time perhaps to scan through a bunch of documents, and needs the answers from charts or from other images within those documents. So to enable this, you go into that developer settings menu and enable GPT-4 with vision, and then you can actually just start to ask questions around those charts that I showed you before. So in this case, I've asked for the expected trend over the next 5 years, which was in one of the, and then compare it to the past 5 years of S&P 500 performance, and that was one of the charts that we had. And then the answer is that, hey, the expected trend for the S&P 500 index over the next 5 years shows an upward trajectory. So we know that, and it even gives you citations for the specific PNG files as well. So we know that it interprets those, it generates embeddings for certain parts of that chart. And then when you want to interpret that, it essentially uses the same search engine, AI search engine, as it uses for text search. It does the same thing with images. And if you click on the, skip that, but essentially if you click on the image, it opens up the image. Generate query. So yes, similar thing. So this is with vision. We generate the search query here, which is expected trend for the S&P 500 index. That then finds the relevant pages. So in this case, it's found this. Internally, Azure AI Search has used the embeddings here in order to get this result. So it has embedded the PNG file that you've put into AI Search initially. And then all it's doing at runtime is it's just saying, okay, this is the query. This is the vector embedding for the query. This is the most relevant result. And that's the embedding for the most relevant result. And in terms of the content, it's actually generated, a bit of content as well. Awesome. And then, you've got the images in there. There are a million different possibilities when it comes to using retrieval augmented generation, or even OpenAI in general within an organization. What we've found is that some of the most interesting use cases that I've seen is I saw a medical use case where we're using it to, with doctors, they write in quite cryptic messages in their computers or in their systems, right? After they see a patient, they write in a format where not everyone would be able to understand. One of the most powerful use cases that I've seen is then translating that with utilizing RAG and fine-tuning to a certain extent, although the model that I saw didn't even have any fine-tuning, but you could definitely embed that in there as well to interpret what that message meant for other hospital staff who maybe don't know that can't read that script fully. And that means that we're saving patient lives because, with translating those things faster, every second counts. So it's important for us to be embedded in that kind of space. So possibilities are endless. You can use it to pass through a bunch of different documents, wiki pages, SharePoint pages, etc., and generate a user interface that it's easy for agents or other people to to interact with. This is the overall architecture. Now, this was presented in a conference 2 years ago, but funnily enough, the overall architecture of Copilots has actually remained fairly similar. There are some changes here around the UX and plugin extensibility that has changed over the past couple of years. But in terms of grounding, which is your retrieval augmented generation and prompt response and filtering and using the meta prompt, they haven't changed as much. Definitely the foundation models and how you use them has stayed fairly constant. This is the architecture. This is what I was looking for before. This is more of the production architecture that you might use. So you'd probably, as I mentioned, put in Cosmos DB to store your chat history and retain that chat history so that you can then send it with every request that you make to Azure OpenAI. You'd also use functions as well to parse your documents and maybe have an automated document loader pipeline. So as you add more and more documents, you don't have to redeploy your entire solution just to parse one extra document. So there's that. And then there's the Azure Speech Service as well. I know that it's 6:52, so we've got about 8 minutes to go. But I wanted to touch briefly on the other Azure services as well. So we've got a myriad of application hosting services, AI services, database services, and services to make your developer experience better. And these are, we have a whole toolbox. These are a whole toolbox of components that will help you to make great chatbots and great chat experiences for your users. It's our vision, not only myself, but also Microsoft in general, that copilots and chatbots will be embedded in every application in the future. It'll become as ubiquitous as phones are today. So what we want to do is help companies get a head start to provide the tools and the processes to be able to deploy AI safely and to deploy chatbots safely within their environment. That's why we're giving tools such as APIM, for instance, to manage and rate limit and secure your API endpoints for Azure OpenAI. We have Kubernetes or App Service or Cosmos DB, so you can scale your chatbot for thousands and millions of users that ChatGPT has every day, for instance, and that they're all running on Azure. So we provide essentially a developer platform that's engineered to make your experience using OpenAI or developing on OpenAI as easy as possible. In terms of next steps, so we actually have another part 2 coming. You can scan the QR code on screen there, or just go onto that meetup link and register yourselves for that. And that one will be more about an in-depth conversation around production-ready copilots and how you can get started on that. But yeah, that's all that I had in terms of content. Now I'd like to go on to answering a few more questions. Yeah, Jyotsna, did we have any other questions? Maybe you want to have a go at answering one?
Yeah, sorry, I cannot for some reason use the comment to reply back to any of the comments, but I was searching for a case study for that previous question, which I did found. So I will pass it on to Nadia or yourself, and you can comment back to the person. But in terms of questions, I think the next question that we had was, does it also depend on the model used to create these vector embeddings? Have we already answered that, Deep? I don't think so.
Okay. Well, we did touch on vector embeddings. I think there's a few duplicate questions in there. But essentially with that, we are using the ADA model. That's the baseline model that we're using to generate these embeddings. There are a few that you can use for embeddings, but the results don't differ that much. It's more to do with the GPT model that you use for actually generating the output, not so much the embedding model. It doesn't make too much of a difference as long as you're consistent. Are we using OpenAI models? So that's the same question. We don't send GPT vectors. I've answered that. We don't. Sorry. How does AI search plus OpenAI performance compare to creating training open source LLM? When would you try using your own LLM? OpenAI search for performance. Okay. So training your own open source LLM is quite a process. Firstly, you need the computing power to be able to host your own LLM. The way that we're able to get the latency and the security and the rate or the scale that we have for OpenAI, the way that we're able to do that is we have invested, just in the ANZ region, we've invested about $5 billion to create production-ready servers to host these LLMs. Now, yes, you could create your own LLM and train it. It would be quite costly to host because LLMs are quite power hungry, particularly with GPUs. But more importantly, you would also then need to figure out scaling. And one of the great things about GPT-4 at the moment is that you can start with a pay-as-you-go model. So you can scale from 0 up, and then as you get further and further up, you can contact us and we can get you onto a PTU license, which is more of a reserved instances type of license. So you reserve a certain compute for your company. So we do have those, and we can facilitate that for larger use cases. So yes, you can. OpenAI is one of the best models at the moment. You can use some other models as well in Azure OpenAI itself, or Azure AI itself. I think Facebook's model is one of them, but the one that I have the vast amount of experience with is that OpenAI model. If I want to run a logic layer on top of RAG, something like intent recognition, how do I go about it? So you would need to put it into the pipeline that we showed before. This one here. You'd probably place it either in, actually even before. So you'd either place it in this retrieval function here if you want to run that logic on the user query. But be very careful about doing that. I've actually had companies where they're running this embedding model after the user query, which means that this function takes way too long to run. So if you do have logic that can run before the user's input, definitely place this into the document loader here, especially if you look at the production ready one. There's an Azure function that we've recommended in there, or logic app. So probably the best thing to do is to put that logic layer into that logic app or Azure function. And yeah, if you want to do intent recognition, 100% you can do that. So it depends on whether you wanted to understand the user's intent, like the person who's using the chatbot, or the document's intent. But yeah, you can use the relevant function for that. Did you want to take one of these, Jyotsna?
Just having a look at the next question.
Yeah. So the next one is it possible to call on-prem LLM instead of OpenAI by using Azure AI Search? Yeah, I don't see why not. Sorry, did you want to say something?
No, go for it. You're the AI expert, Deep.
No, we're both AI experts. It is possible. You'd need to, yeah. So essentially, you would be using your answers from AI Search. So you'd be retrieving the answers from AI Search, and rather than passing that to OpenAI, you'd be using the on-prem LLM instead. So I don't see why not. But you'd need to, yeah, if you wanted to do private networking and things like that, you'd have to get that organized. So have an express route, organize private networking, and then you can definitely use that. I'm aware we are at 7, but we do have a few more questions. So I'm happy to keep answering as long as everyone's okay to stay a little bit longer. I am completely new to this. Awesome. Thank you for joining us. And this was meant to be the beginner kind of part. So we'll do it in 2 or 3 parts. The first part will be the beginner part. So I'm glad that you joined us here. If I want to create my own Copilot for the same example of sort of policy documents, what are the prerequisites that I should know? Awesome. I think, Jyotsna, you've deployed this, right? Do you want to talk a little bit about how you did that, what sort of skills that you needed?
Yeah, so I almost deployed it. So as I showed you in the beginning of the presentation, you can use, to get started, you can use that open source demo, which I think Deep will provide in the resources tab there, which have all the prerequisites that you need to spin up this Copilot. Again, it didn't take me that long. I did run into a few issues, but yeah, it didn't take me that long at all. In terms of programming skills, honestly, you be familiar with a bit of Python, but don't need to be a coder to spin this up. It's fairly easy. But yeah, anything to add there, Deep? How was your experience?
I think with my experience was very similar to yours. I think with any programming, right, you always think that, hey, it's just a Git repo. We even showed you the commands to clone the Git repo, run azd up, and in theory, you should be up. In real life, that's not how technology works. You go and you type in azd up, and then you realize, uh-oh, the version is wrong, or something didn't deploy correctly, or there's some other issue. So when you get those sorts of things, we do have on GitHub, we do have an issues tab, so you can post there. You can also post on Stack Overflow or other forums. These search demos, they have quite good outreach. So there are quite a few people who have used this and have deployed it. So I'm sure there'll be people that are happy to help. You can reach out to us as well. I think I've got you can reach out to me on LinkedIn. You can look up my name, and Jyotsna's on LinkedIn as well. So feel free to connect with us, and we can, go through your use case. And also, if you do have some trouble, we can see if we can help out. So the prerequisites that you should know, probably just a little bit of coding would help, but don't make that a reason why you don't try out these models. I think you should try to deploy this anyway. And whenever you run into a problem, you should try to Google it and figure out the solution. That's how we all learn, no matter what skill level. So let's just start with that, and yeah, you can work from there. If you do want to find out more about the models and the embeddings themselves, I would recommend reading a bit more about data science and the different models that are involved. You can look on Reddit. There's a bunch of book recommendations for data science and getting started with the different vector models. But you don't need to know that to deploy this one in particular, this demo in particular. Okay, I'm not familiar with AutoGen, so I'm not sure about that question. But for the next time, I can have a look into it and get back to you on that. Some tutorial on how to use this on SharePoint folders. SharePoint actually has a Graph API, so you can definitely use that for creating something like this, where you pass the prompt rather than using Azure AI Search. You use SharePoint to search, and they have their own semantic search model in there. So technically, yes, you could use the SharePoint Graph API to achieve this. There's no demo that we have as far as I know, but you can have a look for if there's any community contributed demos. Awesome. I think we're at the end of the questions for this session. Thank you so much for coming, everyone. Is there anything else you wanted to add, Jyotsna, before we close
No,
out?
I think that's it. Thank you so much for having us, everyone. This was my first Microsoft React event, so I enjoyed it thoroughly, and thank you, Deep, for that presentation.
No, thank you, Jyotsna. Thanks for coming on board, and I'm sure we'll have many more from you. Thanks, Nadia. Take it away. I'm not sure if you're talking on mute, but can you hear Nadia?
I can't hear Nadia. No. Wait,
Oh,
did we
no.
lose her?
We may have, but
Oh,
I'm sorry, Nadia.
it's all right. I think
Awesome. Well, thank you everyone for joining us. And yeah, feel free to tune into the next session for Reactor.
thank
Thanks,
you.
everyone.
Thanks, everyone.
Thanks. Bye, everyone.